In this video, we're gonna try to find two numbers, any two numbers, a and b, that will satisfy the following conditions. The sum of the two numbers is 1 and their product is 1. We'll see if we can find such numbers. A good approach to solving this problem is to see that we can solve for one of the variable and plug it in one of the equations and plug it in the second one. And from there, we solve for just one variable because we have two. So we can solve for b and plug it in the second equation. Let's call this one first and this one second. We can solve for b in the first one and plug it in the second one and solve for a. That's what we're gonna do. In fact, we have b is 1 minus a. And if we plug that in the second equation, we're gonna have a times 1 minus a equals 1. So we're gonna start working with this equation to find a. Once we find a, we plug back here to get b. So here, let's work with this equation. We have a times 1 minus a equals 1. So doing the algebra, we get a times 1, which is a minus a squared equals 1. So we put everything in one side. A minus a squared minus 1 equals 0. We multiply everything by minus 1. We get a squared minus a plus 1 equals 0. So here we notice that we have a quadratic, okay? A polynomial. So we try to factor it out. Okay, remember in doing this quadratics, we need to find these two, because you remember that we have a minus b squared is a squared minus 2ab plus b squared. We have to find these two. If we don't have it, we just multiply by 2 and we divide by 2. It's 1. This trick always works. So let's do this one here. We have a squared minus 2 times 1 over 2 times a. So we see that these two has to be there all the time. And the 1/2 is b. So let's treat 1/2 as b. So we have 1/2 squared minus 1/2 squared. So here we use this trick too. So it's like we adding and subtracting the same thing. It's 0 plus 1. Okay, notice what we did. So we did this trick here to have these two because we need it when we complete the square. And also we need the b squared. So we had, from here we noticed that we have a, we need b is 1/2. So we notice that the b is 1/2. So in this case, we need the b squared, which is 1/2 squared. So we did 1/2 squared minus 1/2 squared. It's plus b squared minus b squared, which is 0. It's like we did nothing. After that, we're gonna notice that this is what? This is a minus 1/2 squared. And here we have minus 1/2 squared plus 1, which is 3 over 4. Okay? So now what can we say? This equation can never be 0. Why? Because this number is square. It's always positive. Okay? So a minus 1/2 squared, call it x squared, big X. So it's always bigger or equal than 0. Okay? And when we add 3, so let's have x squared plus 3 over 4, which is a minus 1/2 squared plus 3 over 4. It's bigger than 0. So that means this one can never be 0, and therefore there is no a that can satisfy this equation. And if we can't find an a, that means we can't find b. That means this system has no solution. There is no a and b that will satisfy this one. Some they might say, let's solve it in the complex. Yes, we are not talking about complex numbers. We're talking about real numbers. So let's say here a and b real. Okay? The complex numbers, yes, we can solve it in complex number, but we are interested in the reals. Okay, complex number, we need them in electrical engineering or some other stuff. But here we see that we can't have a and b real such that a plus b is 1 and ab is 1. There is another technique when we get here So once we have this one here, without doing all this, we can just say we have a squared minus a plus 1. So this is a quadratic. We can use the discriminant. We can use delta, which is b squared minus 4ac. The b is minus 1, so minus 1 squared minus 4. The a is 1 here. The c is 1, so minus 4 times 1 times 1, which is 1 minus 4 minus 3 is less than 0. If you have the discriminant less than 0, that means you can't have real solutions. That means there is no a that solves this one. And since there is no a, that means there is no b, and therefore there is no a and b that will satisfy this equation. Okay, thank you very much.